Hi, my name is Jennifer Wetzel. I'm the regional coordinator for the Philadelphia Future City competition. I'm really excited that everybody could be here today. This is the virtual version, the 2020 version of our engineering fair, where we try and give students who are either thinking about Future City or already involved in the competition this year some information and just to be able to move forward and get some knowledge about the competition, and especially about the themes we have every year. So for this presentation, I'd like to introduce Emily Law. Emily is a project manager and principal computer scientist at NASA's Jet Propulsion Laboratory. In addition to serving as the project manager for development and operations of NASA's Solar System TREX, she has program and project management appointments to 3 JPL program offices for data science, data-intensive system and technology projects in earth science, planetary exploration, and enterprise data and analytics. Thank you very much, Emily, and can you take it away?
Thank you, Jennifer. Appreciate the introduction. Let me see if we can share the screen.
Share, and let me make sure I am recording.
Is it working?
Yes, your screen share is working, and I am recording.
Okay. Let's see. No, I'm not. I'm not able to, for some reason, move forward with this, but let us see. Okay. All right, this is better. So thanks, Jennifer, again, and hello, everybody. Thank you for tuning into this presentation. I'd like to thank Mr. Ken Gokins also for this invitation to give this talk about MoonTrack, which is a tool that I hope you can use not only for the exciting future city competition, but also for your curiosity and study of the moon in the future. So I will begin with some worth-looking background and facts about the moon and also lunar exploration. So the first lunar missions was conducted by the Russians in 1959. Lunar 1 orbited the moon, followed by a landing not long after by Luna 2. Several more missions were conducted by the US and also the Russia leading up to the Apollo program. For some reason, I can't move forward. So Apollo 11 launched on July 16, 1969 from the Kennedy Space Center. Neil Armstrong and Buzz Aldrin took the first step on the moon on July 20th, 1969. Many of you probably participated in one or even more events that celebrated the 50th anniversary of this historic moon landing last summer. So early research on the moon include 5 passive lunar laser reflectors. 3 were installed on the surface of the moon by the landing crews of Apollo 11, 14, 15, and the other 2 were mounted on the 2 Russian rovers. Lunar laser reflectors analysis provides high precision measurements of ranges between observation on Earth and the reflectors on the moon surface. It measures metrically the dynamics of the Earth-Moon system. The study helped us to improve the knowledge of the moon's orbit, the variations in the rotation of the moon, and also the rate at which the moon is receding from the Earth. That's how we know today that the moon is moving away from our home planet, the Earth, approximately about 3.8 centimeters per year. There were 6 Apollo missions with successful human landing. all on the near side of the moon. Even though the Chinese had successfully landed their rover on the far side of the moon in December 2013, I believe, no humans had yet visited the far side of the moon. Now, this video was created with Moontrack, flying down to the Apollo 11 landing site, the Tranquility Basin. Moontrack's interactive visualization feature allows you to make flyover movies like this one on your own. And I'll talk about the tool more later, and hopefully there will be time to even give a demo. Here you can see what the Apollo 11's artifacts are left behind, including the lunar module, which was the first crewed vehicle to land on the moon, and the seismic instrument that detect and also measure moonquakes, and also the reflectors that I talked about earlier. Between 1969 and 1972, the 6 Apollo missions brought back approximately about 382 kilograms, about I think it's 840 pounds of lunar rocks, core samples, pebbles, dust, and also sand from the lunar surface. The 6 Apollo flights returned over 2,000 of the separate samples from the 6 different exploration sites on the moon by the Apollo missions. The Lunar Sample Building at Johnson Space Center in Texas is the main repository for those samples. It is the facility where pristine lunar samples are prepared for shipment to scientists and educators. It is a facility where we send out those samples to just specifically for the projects, for teachers, and also for the research. New discoveries continue to be made using those samples nowadays. For example, last year, Dr. David Quinn, who is a well-known lunar scientist from the Lunar Planetary Institute, has identified one of the samples brought back by the Apollo 14 to be the oldest Earth rock known. In his research paper, he hypothesized that the rock was actually ejected from the Earth and landed into the moon's Imbrian crater about 4 billion years ago, possibly during an asteroid impact on Earth. There was a long gap with only a few lunar missions after 1972. It wasn't until 1990 that the countries around the world started to conduct more missions again. This mission studied the moon and helped to discover water on the moon. Now, thanks to the newer missions, we now have very high definition images of the near side and far side of the moon. As you can see, their look are distinctly different. The dark areas of the near sides are basins filled with basalts formed by ancient volcanic eruptions. And the far side does not have this feature and is known to have a way thicker crust. This topographical maps of the moon shows that the near side has mostly really flat basins, while the far side has what are known as the highlands. These are the types of map you can find and looked at using the Moontrack. You can also take a look at some of this and other types of map during the demo later. Now you can see the distinct outline of the area of the South Pole Aitken Basin. This is an impact crater roughly about 2,500 kilometers in diameter and 13 kilometers deep. It is one of the largest known impact craters in the solar system. It is also the largest, oldest, and also deepest basin recognized on the moon. 5 decades ago, NASA had the successful Apollo program that landed the first man on the moon, as we know. Now today, we have the Artemis program with a goal to return human to the moon by 2024, which including the first woman and the next man. We are talking about really not that far in the future. This mission is targeted for the moon's south pole, and the Artemis program's ultimate goal is really to achieve a sustainable human presence on the moon, potentially even by 2028, providing a foundation to build a city on the moon. The program also includes a crew-tended spaceport in the lunar orbit that will serve as a gateway to the lunar surface as well as to the deep space. The lunar gateway will serve as a small habitat for the astronaut to do their research there and to travel back and forth to and from the moon. Bottom line is that the moon holds really amazing opportunities for future science, exploration, habitation, and even tourism. Can you imagine just having a vacation on the moon? If that is really a dream of yours, and I think that it will come true. We will develop ways to live on the moon. We will build the infrastructure, and we will look to mine critical resources for permanent stay on the moon to continue exploration, and even bring back some of those resources back to the Earth for use. It is truly an exciting time for us. There are many opportunities for you to be a part of the future exploration activities. A participation in this future city competition, designing a city on the moon, is a great start. And it'll be challenging, fun, and also a great learning experience. So, what is Moontrack? Moontrack is a tool for you to explore the moon on your own computer. It is free to use. It does not require downloading any software. Just enter the URL track.nasa.gov/moon onto your web browser. Try it on a Chrome browser, for example. Moontrack is used by NASA and its international and its commercial partners to plan and execute activities for future moon expeditions. My hope today is that it will become a valuable tool for you to find, visualize, and analyze the wealth of data returned by past and current lunar missions, and that it is a useful resource to help design your lunar city. Moontrack is just a member of the NASA Solar System Tracks family. The family of track portals provides interactive visualization and analysis tools for engineers, mission planners, scientists, as well as the public around the world to easily access and view a large amount of the data in both 2D and 3D, and also to analyze those data. The data are returned from past and current missions for a growing number of planetary bodies. So in addition to Moontrack, on the Solar System Track home site, track.nasa.gov, you will find and can access 8 other of its sibling portals publicly available today for you to explore other distant worlds at your fingertips. So simply click the Explore Track button there. And then you can choose from the menu to start exploring, for example, Mars, Mercury, Titan, which is a icy moon of Jupiter. Or you can directly go to each of the portal using its own URL. As you can see, very simply, just type track.nasa.gov/ and then add the name of the planetary body that you are interested in exploring and go flying. Now let's take a closer look of the Moontrack. It starts by giving you an option to take a really short tutorial that will guide you through how to use the portal's buttons and features. I would strongly recommend taking the tutorial just the very first time you use. And once you get to know the features, you can just check the box. Do not show this dialog again to skip the tutorial. With Moontrack, it is easy to control the viewing of the moon from afar or close up by panning and zooming using your keyboard, touchpad, or computer mouse. So here we'll zoom down to my favorite moon crater called Tycho. This is done in the default global 2D projection. You can easily switch to other different projected views, including 3D globe or polar views. And here we're switching to the 3D globe view, in which you can then use the game control keys on your keyboard to maneuver fly over across the surface. I bet that you all are expert using the game control keys from your experience playing various video games. But if not, you can also manipulate the flyover using joystick or a 3D mouse. So again, for example, we'll fly down to the Tycho crater floor and then drive up towards its central peak. Now, Moontrack has a set of tools. You can find the tools on the tool menu. They are available for you to use and do not require you to log in. For example, you can generate an elevation profile by simply drawing a line to measure the heights of the mountains and the depths of valleys. In addition to drawing a straight line, there are other options to draw curvy lines, and I will demonstrate those later. And you can also export the numeric values to a spreadsheet for later analysis. There is a Generate 3D Print File tool that allows you to draw a bounding box around any area of the terrain you want to generate output, and can then be sent to a 3D printer in order to create a physical models like the one shown here. This could be useful for your competition to have a 3D print of the area where your city will reside. And if you have access to a printer, that is. The Experience Track VR tools allows you to draw, excuse me, any path you want anywhere across the surface. The portal then provides you with a QR code. You scan the QR code into your smart Android phone or simply point your iPhone camera at it, and you'll be given a URL to download the data. Once the data is downloaded, you slip your phone into a pair of inexpensive cardboard-compatible goggles, and you can then fly across whatever path you drew in virtual reality. Perhaps your competition deliverables can also include a VR flyover experience as well. One caveat is that if you happen to have an older version of iPhone, you will need to go to the Safari setting on the phone to turn on the orientation and motion in order for it to work properly. Now, Moontrack has the ability to combine data sets from different instruments and from different spacecrafts, simply by stacking and blending them together to create a customized view, which can then be easily shared with others. For example, we are looking at the Marius Hill on the moon here. This area is known to have the most spectacular concentration of volcanoes on the moon. But wait, you can't really tell by looking at it with the base map here, which is created using images taken by the wide-angle camera aboard the Lunar Reconnaissance Orbiter, which, by the way, is currently still orbiting the moon. However, once two other data sets from two different instruments aboard two different spacecraft are added, you now can clearly see the volcanic cones popping up here. And if you add this colorized gravity map from the Japanese Kagoya spacecraft on top of the same area, and then use the layer menu to control and change the opacity using the transparency bar, you can now clearly visualize the surface topography of the volcanic field as well as the now solidified unerupted magma chamber beneath the complex. You can then easily share this customized view by sending the URL to your friends. And when they enter the URL onto their browser, they will be taken to the Moontrack and see the same data sets that you created. If you have your own website, you can even embed this view onto your website. Now let's turn our attention back to the Future City competition. This year's challenge is to design a future lunar city and provide examples of how your city uses two moon resources to keep your citizens safe and healthy. So what are some of the things that you might want to consider when you're planning your future lunar city? You can start by giving some thoughts on what elements are indispensable and required in order to live on the moon. For example, for us humans to keep alive, we must have air to breathe, water to drink, and food to eat, etc., etc. So what kind of resources are there that can be exploited to sustain life on the moon? Just imagine, the moon is far away. It's going to be very difficult for us to transport everything we need over there. So thanks to the past and the current lunar missions, the data they collected, from them tell us that there are volatiles on the moon. They are chemical compounds from which we can extract H2O and oxygen, etc. I'm hearing some background noise. Okay, thank you. And there are also plenty of minerals that we can use on the moon as material to manufacture things or construct buildings, etc. You would probably want to build a city where those resources are nearby and make it easy for mining. So what about geologic features? Are there natural geographical structure that you can take advantage for shelter, for example? Other important factors to consider include communication back to the Earth and also landing site that should not be hazardous. So if you want to think about design your city at a location of a moon where direct line of sight is important, to the Earth from the moon, and make sure it's visible, and also maybe an area that is smooth, no large hills, no tall cliffs, nor deep craters, which could cause incorrect altitude signals to the landing radar in the path during approach. Moontrack can help you find maps of different resources on the moon. Here are a few examples. This is an iron concentration map based on data sent back from NASA's Clementine missions conducted back in 1994, showing the abundance of iron across the moon. The low iron concentration is shown in blue color, and where red indicates high concentrations. Here is another example. This is a hydrogen concentration map based on the data sent back from NASA's Lunar Prospector missions conducted between, as I remember, 1998 and 1999, showing the abundance of hydrogen across the moon. no hydrogen concentration is shown in lighter color versus the dark blue indicates higher concentration. Here we take a look at the South Pole. This is an ice exposure map based on data sent back from NASA's Moon Mineralogy Mapper instrument called M3. It is an instrument flew aboard the Chandrayaan-1 mission, which is an Indian first mission to the moon, conducted between, I think it's 2008 and 2009. This data represent the distribution of water ice in the South Polar region. So we know where to find water. Here is another map of the South Pole view. This shows maximum temperature based on data sent back from NASA's Lunar Reconnaissance Orbiter that I talked about earlier, which was launched in 2009. It stands for LRO, which is still orbiting the moon today, bringing back large amount of data back to us. This data shows the maximum temperature distribution in the center of the South Pole regions. The lowest temperature is around 25 degrees Kelvin, which is equivalent to approximately minus 400 degrees Fahrenheit. It's shown in the purple color, versus the brightest red color indicates a higher temperature, around 200 degrees Kelvin, which is about minus 100 degrees Fahrenheit, I believe. And you can imagine how cold it is. So that's probably not an area to build a city. Well, I'll stop here and thank you for listening. And we can use the rest of the time perhaps to do a quick live demo and or open up for questions.
So if there are any questions, please put them in the chat. Well, you want to go ahead with your live demo
Okay, hold on a second.
while
Let me
people are thinking
grab
up
it.
questions?
Sure. Let me pull up the browser. All right, let me share my screen again. Don't know what that means. Can you see my Chrome browser?
Yes, we can.
Okay, so we'll
Yes.
start to go to the solar system track. Here's our home site. As you can see, so let me make it smaller so I can see it too. So you click on export track, then you have all this option to export. And so let's go to moon track. Oh, actually, before I do that, I'll let's take a look at some other things on the home site that might be of interest to you. For example, there's galleries. If you go to galleries, there's actually a section that shows what we call feature of the month. Each month we put up some interesting maps or features that we want to showcase. So the last one we shown here is Bennu, but let's see, and then you can go back and look at other ones as well. And then there's some videos that tell science story. For example, this is particularly for the moon. So we will talk about the volcanoes on the moon. And there is, I talk about the Experience VR tool. So in addition to, the tools that you can find anywhere area that you can draw a path, we have some pre-made tours that we created here. So for example, there's all the Apollo landing site and also possible, landing sites on the moon. So we created those paths. If you click on it, and you'll get the QR codes, and then you can just use your smartphone to capture the QR code. And also there's here that we have some description about the different features that we have. One of the things that might be of interest is that not only we provide these web portals for you to use, but we also provide a set of APIs for you to be able to access our data. If you're writing a program, you want to be able to access data program about these, then you can actually use this type of services that we provide. So it's give you a set of layer services. You can actually access the data directly. And we have also links to other resources you can look at as well. So let's go back home. Let's start exploring the moon, which is really the topic today. So we click on moon and have a little description here, and then we click explore, and it takes you to Moontrack. As I said, the first step would be you will be able to do a tour. So if you start the tour, it will just basically step by step take you to show you what are those features are. So go to stop here, and you can do the tour on your own. So here is where you can zoom and pan, either using the keys here, using your mouse pad, or using just the touchpad on your computer. One of the features is that you can fly to anywhere that you like. For example, if you know the nomenclatures, the name of the area that you want, you can use this button here, fly to. You can type in the latitude or longitude, or you can type in the name of the feature that you want to explore. So in my case, again, I like Tycho Crater. Click on this. It will just take you there right away. So again, you can still from here zoom and pan and take a look at the crater that way. Let's see, zoom back out a little bit. One of the feature here is next to the fly to button here, there is a button for you to look at what is the base map, and also this is where you can turn on the nomenclature. So nomenclatures are the names of the features that are designated by the International Astronomy Club, I think. And so if you click on that, and you will see the different names that was designated on the moon. Okay.
We have had a
yes.
few questions come in.
Sure, go ahead. I'll be
there?
happy to answer the questions while I'm doing this. Yes.
Okay.
Yes. I'm ready. I can't hear.
Okay, the first question is, why do we need certain minerals like lithium and potassium for survival on the moon?
Lithium is, you can make battery, for example. So different mineral have different usage, and some of the mineral, it's really, a lot of those are for constructing things, and you can extract, the different composition from different minerals to be able to help you make things that you need to live on the moon.
And in particular, when we start having greenhouses and growing things on the moon, the soil there, well, the regolith there does not have everything that we do on the Earth, and Potassium is required for plant growth. It's one of the minerals that is required for plants.
Next question, can lava tubes be seen on Moon Trek?
Yeah, yes, I believe so. I don't know if we have maps that actually shows you that. So if you go to search here, you can go to the product type and you can find what are the different type of products that we have. We have mineralogy, we have images, landing site, geology, map. So I think there are, data that you can, if you know where they are, you should be able to find them on using Moontrack. We have terrain, we have topography, some of those images that will contain some of the lava tubes, or at least where the lava tubes are.
So it'll be a treasure hunt.
That would be fun.
Another question is, how often is Moon Trek updated?
It's updated. Let's see. It depends. It depends on how much information, new information we get. If we have new data sets that we think is important, so we'll add to them. So there is no periodic update that we make, but it's more like on an as needed basis. Whenever we have new information we want to add to it, we'll provide it, unless there is a major enhancement with capability. For example, new tools that that we add to it, then we do a major release. So for example, recently we added a tool called rockfall analysis. Well, what does is allow people to be able to go to an area of the moon and see if there's rock falls. And then we make a release of the tool.
Okay, next question. What is the moon made up of and how long would it take to walk around the moon?
That is a very good question. I have to apologize ahead of time. I'm actually not a lunar scientist. I'm a computer scientist. So my responsibility is actually to develop this tool. So some of the scientific question is I would not be the best person to answer, but I do know that the diameter of the moon is about 68 kilometer. So you're talking about, possibly the length of going from the west coast of the United States to the east coast and return. So imagine, I don't know how long it takes to walk from, say, California to Boston and come back. So that's a good question.
More than a summer vacation.
Yeah.
Yes, yes. Probably more than anybody want to try to do. But then if you have a, eventually, when we build a city on the moon, then you're going to have rovers there and that would help.
So those are the questions we had right now.
Okay, so I'll continue the demo. So I, talk about using the, showing the elevation profile. In here, I can do an example. You can do a freehand drawing here. So I can draw a line here to say, what is the profile around the rim of the crater? And first of all, it'll come back and tell you that it's about, 562 kilometer. And once you submit it, and in the meanwhile, let me just zoom out a little bit. And now you can follow, if you walk around this crater, you will see that, what is the elevations that you have to deal with if you want to walk around this crater.
Could you do that and draw a line like right through the center of the crater, like all the way across it?
Absolutely. Yep. And now you can easily see that this crater has a central peak right there in the middle.
Yeah.
Yep. Let me show you something else. So we talk about different data sets. So here is where you can manipulate the data. We have different ability to find the data that we have. First of all, it come up with a list of what we call bookmarks. So for example, right here, you click on Apollo 11, it will give you some information about the Apollo 11 landing site. You can add it to the map and it will take you there. And then you can also see there's points of interest that we point out. For example, here, click here, I think. Here is where the lunar module descent stage, the lander is right here, that you can have some, take a look at the description of the lander. One of the very interesting fact here, if you click on this, what we call the big west crater. So what happened is the Apollo 11 landed on next to the small west crater. And here is the west crater. So what it tells you is that Apollo 11 was originally planned to land on as flat and smooth a site as possible, but various uncertainty associated with the first human descent to the moon surface led to lunar module Eagle flying a path further to the west than originally intended. As Commander Neil Armstrong looked out the window, he saw the lunar module's flight computer was taking them down towards the crater 180 meters across and surrounded by a field of large boulders. The boulders are bigger than the football field that we have. So realizing that they could not land in or too nearly to the west crater, Neil Armstrong actually took manual control of the lunar module and flew it further west until he found a safer location for landing. That's why they end up in this area, a little bit west to the little west crater. So I think those are interesting facts that you can find on the portal. So other than some of the bookmarks, is you can see that we have 9,949 products that you can look at. So in order to narrow down finding what you want, one of the abilities is that you can do spatial search. Now let's fly back to Tycho, for example. Right? And then we will use the spatial search capability. And let's try to find what's in this area. So once you draw a box of the area that you're interested, it will come back with the list of the data sets that you can find within that area. And then you can actually hover your mouse on them, you will actually see the footprint. And then if you're interested in any of the data set, then you can just add to it. So another way to find data sets is by metadata, which, for example, let's clear it first. If you look at the metadata, you can tell that, what are the data we get back from all these past and current missions. There's a number of them you can choose from, or even down at what kind of instruments the data returned from. So you can pick those as well. And again, from the product type, you will be able to find, some of the mineralogy data that we have. Now let's take a look in the different projection. For example, the 3D globe. Now, you can zoom and you can turn around and look at the entire globe of the moon. Let's fly back to Tycho, which I really like, that you can tell. So let's zoom out. And one thing you can do is, as I say, you can use your game control keys. You click on this button here, and now you can use the game control key to fly. So this is how you can create your own movie in the area that you want to fly across. The other thing I can show you is we look at some of the maps in South Pole. You can go to the polar view here. And then here, if you look for ice, for example, and you have different type of layers. So this is the one that I showed you earlier, the ice exposure. And then you can add it to the pole. Now, one thing I would like to also mention is that for all the data that we have, you can also, in addition to the description of what the map is all about, you can get this detailed metadata. So if you click on it, it would give you some provenance and how we created the data sets and so forth and so on. So let's go back to the global map. Does anybody have any area that you particularly like that we can fly there and explore? If not, is there any other questions? Well, if not, well, thank you, everybody.
Sorry, Emily, there are a few more questions. Some of them are not, I mean, as you said, you are a computer scientist, so I'm not sure whether you can answer them, but I'll throw them out there and we can see if we can answer or not.
If I cannot answer, one possibility is send me an email and I will find the lunar scientist to answer your question for you.
So how is a new moon different from a lunar eclipse?
That would be a scientist question.
Actually, it looks like one of the students seems to have gotten that one, answered that one.
Okay.
Avita Kalman answered it. A new moon occurs because of the Earth's changing viewpoint of the moon, and eclipses occur when the Earth gets in the way of light from the sun.
Yep.
On the way to the moon.
Yep.
Well, Emily, thank you so much. This was a wonderful presentation.
Well, thank you for having me, and thank you for your attendance.
Yeah,
Appreciate
I am
that.
sure we'll see some things in this year's presentations and models that we've never seen before. Well, we've never taken future cities to the moon before, but there's certainly opportunities in the tools that you've showed the students for them to be really creative, and I'm looking forward to seeing them in January.
Great. Yep, I would like to see the result of these competitions, and I'm sure that it's going to be very exciting and
Well,
fascinating.
If you're free on January 30th, you're welcome to join us via Zoom.
Okay,
I will certainly send you an invitation.
great. Thank you very much.
You're welcome.
And have a nice weekend.
You
Bye-bye.
too. And thank you to all the students and teachers for joining us. All right. Thank you, everyone.
Thank you. Bye-bye.
Bye.